Alright, so we move on to another method of partial fractions. So now today it's going to be the third one. So this is now those that have a denominator with repeated factors. So a fraction has repeated factors when one of the denominator factors has multiplicity greater than 1. So a repeated factor is either raised to a power or otherwise occurs in a rational expression's denominator more than once. So for example, if you have a value like x squared, so this is actually a repeated factor. Then if you have bracket x minus 3x squared, and then if you have x plus 3 to the power 4. So all these represent different repeated factors. So now, how do we work with these? Let's check that out. So let's look at an example. So being told to express x minus 3 minus 2x squared over x squared into x minus 1 as a partial fraction. Now clearly this is a proper fraction, so this is okay. We don't have to express as a mixed fraction. So as you can see, when you look at the denominator, we have this value x squared. Now x squared is a repeated factor. So you can actually say that x squared is a repeated factor. And how do we deal with repeated factors? So we're going to let this value be equal to, so what happens is the repeated factor is we're going to use a series of fractions with increasing powers of the factor in the denominator. So now when you look at this value here, so we're going to have increasing powers of this denominator value. So denominator value is x, so we're going to increase its powers from 1 to what we have here. So it's going to begin from power 1 to this power 2. So now we shall have a over the initial x plus b over this x squared. Now if this was x cubed, we would have started with a over x plus b over x squared plus c over x cubed. But now because it only goes, the powers only increase up to 2, that's why we have 2 fractions from it alone. So repeated factors will allow us generate fractions that are actually the same number as the number of the increasing powers. So from 1 to 2. So this is what we end up having. And then this one here, x minus 1, is actually a linear factor, so it's just c over x minus 1. And that's basically how we deal with repeated factors. So now this is what we have. So now the LCM for this is x squared into x minus 1. And then what we can actually see is if we get this denominator divide by x, we are left with x into, because x squared divided by x is x, so we have x into x minus 1 multiplying the a, and then if we get this denominator value divided by x squared, we're left with x minus 1. So x minus 1 times b is that. So when we have this divided by x minus 1, we're left with x squared, so we have cx squared. So now you can see that the denominator values now cancel, and we're left with x minus 3 minus 2x being equal to that. So now we're going to have to look for a quick way of solving this. So as you can see clearly is so this is actually easy to solve. As you can see, if I want to find the value of c, all I have to do is to make x be equal to 1. So I can let x be equal to 1 if I want to find the value of c. So this will become 0 and 0, then these 2 will cancel, and you can easily find c. Then at the same time, I can also see that if I actually want to also find the value of b alone, all I have to do is to just make the value of x be equal to 0. So if I make x 0, I can actually see that I can easily find the value of b. And basically, I believe that's mostly it. And then of course I can find a later on. Now let's see what happens if I make x be equal to 0. Of course that will allow me to find the value of b. So this is what we shall end up having. Then I'll be left with negative 3 being equal to negative b, of which b shall be equal to 3. Then, as you can see, I can actually just go and find the value of c and the value of a directly. Though if I had actually substituted a 1 inside as x, I could also have found c directly, but this is also going to be okay. But since I know one of the terms, I know what b is, I can actually still find a and c by just comparing the coefficients. So what I'm going to do is I'm just going to solve, and I'm going to substitute for where there is a b, I'll place a 3. And then next I'm just going to open brackets. So when I actually multiply this, I have ax squared minus ax. Then here I have 3x minus 3 plus this cx squared. So I'm going to group those values that actually have the same powers of x, and this is what we end up having. Then I'm going to rearrange these terms here so that I have it as negative 2x squared plus x minus 3, so that it's actually easier to compare. So this is what I now have. So now if I equate corresponding coefficients on both sides, I can actually see that 3 minus a, remember we're looking for a and we're looking for c, but now I don't yet know c, so I will not first use this. So I'll just say 3 minus a, I can already see shall be equal to 1, because the coefficient here is going to be equal to 1. So therefore a is 3 minus 1 and a shall be equal to 2. So now that I know what a is, I can now find what c is. So you can also see that a plus c is equal to negative 2. And then we know that a is 2. So I can see that c shall be equal to negative 2 minus 2, which is negative 4. So now therefore, this is what we have. We have 2 over x plus 3 over x squared minus 4 over x minus 1. And that is how we express this in partial fractions. So moving on to question number 2, we're being told to express 4x plus 3 over x minus 1 squared as a partial fraction. So now we can already see that x minus 1 squared is a repeated factor. So as you can see, we're going to group these, and then we're going to group them with unknown constants, but then the denominator shall be increasing powers of this value in that denominator. So we have the initial x minus 1, a over x minus 1, and then b over x minus 1 squared. So as I said before, if this was x minus 1 cubed, we would have had 3 fractions. So they would have had a 3 over x minus 1 cubed. But because we end on power 2, that's why we only have 2 fractions with its increasing powers. So now if I get the LCM is definitely x minus 1 squared. So if I find the LCM, this is what I end up having. And then you can see that these denominator values cancel, and this is what I'm left with. And then we can actually see that the easiest way of finding b is making x1. So if I make x1, I can see that we will have that. So b shall be equal to 7, clearly. So now that I know what b is, I can actually find what a is by just solving. And then I'm going to substitute the value of b as 7. So a into this is ax minus a. And then this is what I have. So now I can compare or equate corresponding coefficients on both sides, and I can actually already see that 7 minus a shall be equal to 3, or of course there we shall get a as being equal to 4. Then I can also see that a here, I can also compare this a to this, and then I can already clearly see that a is equal to 4. So both ways all give us the value of a as 4. So now that I know that, so you can see that our equation becomes 4 over x minus 1 plus 7 over x minus 1 squared, and that is the answer we're looking for. So moving on to question number 3, I'm being told to express 5x squared minus 6x minus 21 over x minus 4 squared into 2x minus 3 as a partial fraction. So how do we do this? I can already clearly see that this is a proper fraction, so that is a good thing. But then I can see that x minus 4 squared is a repeated factor, and then 2x minus 3 is a linear factor, so that is okay. I can work with it like that. So now this is how we express it. We have, so now let's deal with the repeated factor. Actually, let's first deal with the linear factor. So we have x over this 2x minus 3, and then we're going to have b over the first value of the increasing power. So we have b over x minus 4 plus c over x minus 4 squared, and that's what we have right there. So now when I find the LCM, this is going to be our LCM. So this divided by 2x minus 3 is x minus 4 squared. So multiply to the a. So this divided by x minus 4 is x minus 4 into 2x minus 3. So that's what we have. Then this divided by this, we're left with 2x minus 3. So the denominators cancel, and we're left with this equation right there. So now we ask ourselves the question, what is going to be the easiest way for us to find, at least we need to find one of the values for us to find the rest. So as you can see, I can either, there are many ways of doing this. I can let x be equal to 1. If I let x be equal to 4, I can easily find the value of c. Then if I let x be equal to 3 over 2, I can see that this and this will cancel, and I'll be left to, and I'll be able to find the value of a. So any of those ways works, but it will depend. So now I'm going to first let x be equal to 4, and then what we shall see is I can actually now first find the value of c. So if I do that and solve, this is what I end up having. So I'll be left with 35 being equal to 5c, and c shall be equal to 7. So if I also let x be equal to 3 over 2, this is what I end up having. 45 over 4 minus 9 minus 21 being equal to 25 over 4a. And then a shall be equal to negative 3. So when you solve this, you can actually see that this 4 and this 4 cancel. 75, negative 75 divided by 25 shall be equal to negative 3. So a shall be equal to negative 3. So now I can find b by just solving. So now I'm going to just solve, and I'm going to substitute in the values of b and c. Actually, sorry, I'm going to substitute in the values of a and c. So when I do that, this is what I end up having. So now when I open these brackets, x minus 4 squared is going to be equal to x squared minus 8x plus 16. Then when I multiply these brackets, I have actually have this value here. So the x minus 4 times 2x minus 3 is going to be 2x squared minus 11x plus 12. And then we now see here is 7. So this is what we have. So when you open those brackets, I have negative 3x plus 24ax minus 48a plus 2bx squared minus 11bx plus 12b plus 14x minus 21. So now I'm going to group terms that actually have the same powers. So now when I do that, this is what I end up having. So now I can equate corresponding coefficients on both sides, and I can actually see that this 2b minus 3 shall be equal to 5. So you can actually see that b shall be equal to 4. So b was the only remaining value that I was looking for. So we now know it. So now we know what b is. So therefore we have our equation as negative 3 over 2x minus 3. So now let's rearrange this, and we'll have 4 over x minus 4 plus 7 over x minus 4 squared minus 3 over 2x minus 1. And that's going to be our partial fractions for this complex fraction. And that's the answer we're looking for. Alright, so the next question was a question from UNEB 2020, and this was question number 11. So now we're doing some examination questions. So this year we're told to integrate this question. So we're being told to express 2 minus x plus x squared over 1 plus x into 1 minus x bracket squared into partial fractions, and hence evaluate this integral where there are limits over half and 0. So what we do is, obviously we're going to first express this complicated or complex equation here into partial fractions. Now we can already see that 1 minus x bracket squared is a repeated factor, and this one here is actually a linear factor. So we're going to treat this value here the way we treat repeated factors. So now we're going to let that value be equal to a over 1 plus x, obviously because this is a linear factor. But then now for the repeated factors, we're going to have b over 1 minus x for when it is to the power 1, and then c over 1 minus x squared. So that's what we have now. So now when we find the LCM is 1 plus x times 1 minus x bracket squared. And then we can actually see that when we get this value here divided by 1 plus x, we have left 1 minus x bracket squared. Multiply that to the a. So when you get this divided by 1 minus x, we're left with 1 minus x brackets. Actually, when you get this divided by this, we're left with 1 plus x times 1 minus x with to the power 1. So when you get this divided by 1 minus x squared, we're left with 1 plus x, and that's what we have. So the denominator is cancelled, and this is what we're left with. So now we can see that there are quick ways of at least solving. We can actually see that we can, if we want to find the value of, a, all I have to do is to make x a positive 1. That will actually give me an a. So if I want to find the value of, what else? If I want to find the value of c, all I have to do is to make, actually that's also the same right there. Yeah, and if I want to find the value of a, actually I have to make x be negative 1. And then if I want to find the value of c, I just have to make x be equal to positive 1. So let's see. If we make x a positive 1, obviously that will allow us to find the c. So this is what we have now. So we have 2 minus 1 plus 1 being equal to c. 2c actually. So c shall be equal to 1 when we solve that. So if we let x be equal to negative 1, we can actually find the value of a. So this is what we have. So we have 4a being equal to 4, and then a shall be equal to 1. So we now know what c and a are. So now you can find b by just solving the equation, and then we're going to substitute in the values of a and c. So when you do that, this is what we have. So when you open the brackets, this is what we have. So when you open these brackets, we have b into 1 minus x squared, which is b minus bx squared, and then we have 1 plus x right there. So now we're going to group terms that actually have the same powers. Then this is what we have. So now we can compare all corresponding coefficients, and we can see that we have, remember we're looking for b, so you can actually see that, let's actually use this side. We can already see that 2 plus b is equal to 2, or 1 minus b is equal to 1. So anyhow it will work, but you get b as being equal to 0. So now that we know those, we can actually see that therefore this is what we have. Now is 0 divided by 1 minus x is 0, so we only have 1 over 1 plus x plus 1 over 1 minus x bracket squared. So now next, if we're to integrate the partial fractions, now we'll have the integral of this being equal to the integral of these two partial fractions. So now we can actually clearly see that when we want to deal with this part here, we just have to use u substitution, then we'll have ln 1 plus x. But now this one is a little bit different, but it's also u substitution. So we will make u be equal to 1 minus x. So the integral of 1 over u squared and all that will actually give you a 1 over 1 minus x, and that's going to be our portion for that. And then remember that we actually have limits that we actually have to insert in. So this is what we're going to have. So now on the left hand side, we're going to have on this, we're going to insert where there is x, we're going to put in a half, and then minus that where we actually put 0 wherever there is an x. So 1 plus a half is 3 over 2, and then 1 minus a half is actually a half. 1 divided by a half is 2. Then right here we have 1 minus 0 is 1, so 1 divided by 1 is 1. So that's why I have this plus 1 right here. And then 1 plus 0 is 1, but ln 1 is 0. So that's why we have that right there. So next we're going to open brackets, and then you can see that we end up having ln 3 over 2 plus 2 minus 1, which is the same as ln 3 over 2 plus 1. And then when we press this in our calculator, this is the same as 1.405 to 3 decimal places. And that is the answer they wanted. Now I have an exercise for you that you can actually try out to get better at this part. So these are questions. So being told to express as partial fractions and evaluate the following. So just try this out and perfect your knowledge of this section. So these are 5 questions that are going to allow you to have a better experience of this section. So just try them out, compare your answers to what we have right here, and I believe you will perfect your knowledge of this part. Thank you so much for watching. Thank you so much for watching this video. I hope the video really helped you. If you did, feel free to tell me below in the comments. I'll make sure to get time to read through your comments and to reply to you. And also, if you're new to this channel, I encourage you to join the community by subscribing, and then make sure to hit the notification bell so that you get updated every single time I upload a new video. Again, my name is Emmanuel Olega. Thank you so much for watching. See you in my next video.